Oh wait, I can't see the light from here. Wait, spin it around. Spin it.
Don't boom.
Hey.
Crank it.
What's the silly scope up to?
I mean the galvanator. Now that you think it.
Yeah.
What's that showing something?
Yeah, so what are you seeing on here?
A fluctuation.
The line's going up and down, and so the middle is like 0 volts, and so when it goes above 0, it's like positive, and when it goes below 0, it's negative.
How can it have negative volts?
Yeah, what's negative voltage? What's that going to do to the electrons inside the circuit?
They go backwards.
They're backwards. So even though this, if you look at this light very carefully, do you see how it's flickering a little bit? It's not actually like glowing constantly. It's going like flash, flash, flash. So like the lights in the classroom are doing the same thing, but they're doing it 50 times a second, and our eyes can't pick it up. But because Todd's going relatively slowly, he's going relatively slowly on his winding. When it's fast,
You can totally see that.
we don't see the flickering, but when it's slow, we just pick up that gentle flicker. So each of those is a peak on here. It's either going forwards, off, backwards, off, forwards, off. And so if we take a moment to have a squizzy at what's going on in here, what we've got is just lots and lots and lots of big square loops of wire. And when they're like that, we've got all the magnetic field going through the inside of the loops of wire, and then as they move like that, see how those wires are cutting through the magnetic field lines that go from north across to south? They're cutting through, cutting through, cutting through, and then at that point they're not cutting through, they're just moving along the magnetic field lines, so cutting, 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 parallel, 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 so there's no voltage when it's moving like that, and big voltage when it's moving like that. And so what we're seeing is that as it flips like the, so big voltage being induced, 0 voltage being induced, and so what we're seeing is that as it flips from one way up to the other way up, we're reversing the direction that the electrons are pushed around the circuit, and how that looks is like a reversed current flow, a reversed voltage. So positive voltage, negative voltage, electrons go one way, then they stop, or electrons go the other way. So what does AC mean? Alternating current. Well, what's alternating?
The direction of the current.
No, it's the direction of the charge flow, the current inside the circuit. It's going one way then the other way. And so this is what we get when we plug into the wall. And you plug into the wall, it's going up and down 50 times a second.
How does?
Not like a battery. So a battery gives us DC. When we plug into the wall, when we have a power plant, we've got a water wheel. We don't have someone standing in our power plant doing this thing. We've got a water wheel, a real flash water wheel that goes round and round and makes electricity. But because fundamentally it's just a coil of wire turning around inside a magnetic field, we're going to get that same AC voltage. And actually there's a whole lot of advantages for AC. Make it easier to change from low voltage to high voltage and high voltage to low voltage. AC is really easy to do that, DC is really complicated.